Hello, I'm Stephen Rakusik, South Dakota Public Broadcasting.
I'm Del Droege, Professor of Biology at Dakota State University.
Today we're going to be dissecting the freshwater clam. And we're going to start on the outside, and Dale's going to explain a few things on the outside of the clam before we actually dissect it.
Clams, of course, are members of the phylum Mollusca, and so as such, most mollusks have a hard external shell, so it's one way of spotting these. And clams are actually part of a family of mollusks called the bivalves, and so their shell consists of two halves, and there's a hinge running along the middle part that connects those two, and then it's held together by strong muscles. We think about clams, we usually see them laying there and somewhere like this and flat, but that's not the way a clam lives. A clam actually is more like this. This is the back surface of the clam, or the dorsal surface, and so this would be ventral or lower. And then from this bump called the umbo to the front, you can see that it's a much shorter distance. That's anterior, and this is posterior. So when a clam is moving, it's actually, foot would be coming out and it would actually be moving in this kind of a direction. So you really don't see them like that very often, but occasionally you would.
Like kids might have like a hermit crab at home that has a shell. They're probably used to seeing a shell like that. Do these actually then replace their shell? Do they make their own, or how does that work?
Yeah, no, these animals make their own shells. They make these bivalve shells, and hermit crabs tend to live in, like, say, snail shells and bivalve shells, and they are. But yeah, like you say, hermit crabs don't make their own shells. They inhabit the shells of others, but these animals have a structure called the mantle, we'll see in a little bit, that takes calcium and other minerals out of the water and uses it to construct a shell. So it's really a pretty remarkable process.
Absolutely. And then it starts from where, at this end out?
Starts at this end, and then you can actually see rings where, as it grows, not necessarily annual rings, but as it grows, it leaves these rings, and so the more rings, the older the clam. All right.
And as far as you're talking about movement, are they fast moving
Yeah,
as far as predators? Or
yeah,
how
they move away from predators, or to stay wet, in the tidal zones and things like that, to move and that, or to search out new places to live. And they can move much faster than you might think, although not speedy by
As far as defense,
by
probably go down into the sand?
Yeah, go down into the sand to avoid predators, people think so.
Okay.
All right.
So how would you go about opening this up?
Now when you dissect the clam, probably the trickiest part is actually opening the shell. And the shell, tends to gap slightly, but it's held shut by two powerful adductor muscles located on either side of the umbo, here and here. And those really strong muscles, now with the preservatives, have become very hard. And so it's very difficult to just pull this animal or pry this animal's shell apart. So you want to go in and cut those two muscles so you can open it up. And when I do this, I think almost always use some type of utility knife or paring knife with a thicker blade, because if you try to put a scalpel in there and you're prying and pulling, the scalpel blades can break, and that's pretty dangerous. So,
would you suggest the kids doing it themselves, or more?
Oh, well, you really want to make a close judgment on the age of your class. I think younger classes, you would probably want to cut it for them, or have them pre-cut, or certainly very closely supervise their cutting. But you want to make sure that they know how to handle a knife safely and that they can do that, because you could hurt yourself. Okay, so you take the knife, and you always cut away from yourself. And so I did forget to mention, these animals, when the biological supply houses catch them, and then when they preserve them, they put this wooden peg in here to kind of keep a slight gap in the shell. Otherwise, it'd be much more difficult to get the knife in. So you pretty much always see this little piece of doweling, a little piece of wood stuck in there. But anyway, so now you remember the muscles are here and here, so you want to slide the knife in and then cut through that. This is actually, we were talking earlier, this is like something you'll see at an oyster bar. Yep. This is why people can make a living doing this. Cooking shows. They use very, very sharp knives, which is great, but I don't recommend, just because of the possibility of a cut. But we use, you cut in there. Find that muscle as you insert the knife into there, and then as you press it in that direction toward the top, you'll feel the muscle. You'll feel making contact with it, and then you just slice away. This is not the sharpest knife in the house, but it'll work. Cut through that chain, then flip the shell over. This one's going to be a gap a little tighter. You get in, remember the muscle's up here again. Find that muscle.
As far as how deep you're going, you're not going to hurt a whole lot.
No, you really can't.
That,
you don't want to gouge around in there too much, but that's why it's good to push away from you toward the top of the shell, and that you won't move through that, and so you should be able to cut that.
Because there will be some stuff, some organs and stuff inside of here, but not
you don't want
to
stab around in there. But anyway, I think I probably got enough of that to open it. Some tearing usually. But now as you open that body, you'll see those things. And it's what's I think really surprises students. It really it doesn't look like very much as you open that up. There's you're like, my gosh. But there are some structures. First of all, you look up here, you see this mantle. So you see this looks like a flap of skin or skin-like tissue. And remember, this mantle is what secretes the shell. It lies between the body and the shell. If I just smooth this.
That shell is awful shiny, almost like a pearl.
Yeah, let me remove that mantle tissue. There are those big adductor muscles we talked about. And the shell has this very smooth surface on it called nacre, or mother of pearl. And so this is produced by the mantle, and then it allows the body to, it's real smooth, and the body slides over it and reduces the friction. And it's famous because what happens when sand and grit and things get inside, they'll begin to surround that with this nacre or pearl material, and so you form a pearl. And most pearls look kind of irregular, but there are a few species of oysters and things that produce these very lustrous, spherical pearls that have gem-like value. So you kind of see those. Then you can see along here lying now is the mantle, this skin-like, again, flap tissue. And usually this is a bilateral symmetrical organism, so you usually start to remove some of this. And right underneath there, tilt that up just a little bit, there he goes. These flap-like structures right here have these striations on them, these stripes. Those are the gills. And you can see, again, we've talked at other times about large surface area. Respiratory surfaces have large amounts of surface area. And so these now, as the water flows over them, they extract the oxygen. They're filled with blood vessels to carry that oxygen throughout the body. An interesting thing with clams also is they're filter feeders. That is, they get their food from suspended, or food that is suspended in the water. And the gills actually act as the baskets to catch that food. So as the food passes over the gills, it's caught in slime strings, which are then moved toward the mouth.
Have a dual function then,
yeah.
More so than.
Yeah.
And also, I think the kids should notice too is that, if you look at different things you might dissect, or even going out fishing, there's always kind of a certain look to gills, isn't there?
Yeah, gills always kind of have that striation. Again, a large surface area, a lot of blood vessels associated with them. Here is the foot. This end we talked about how that extends out through the, into the exterior to then that they move, push down into sand, pull them down into the sand. It's full of fluid normally, so in these preserved animals it's much shrunken and it's very tough, but this is the foot area right here.
You mentioned the mouth. What's part we find the mouth on?
Let's look at that one and say we've got one here. We take the one we had talked about earlier. Here we are.
Hold that for you.
Yeah. Oops, this one doesn't have the labial palps either though. Oops. One of those. Is that one? Shoot, did we cut them off? Everybody? I pulled them off. I pulled them off that one too.
Here too.
Yeah, we can start it. We'll do
Go ahead. One thing you notice too, like when you dissect any organism, you'll notice that the parts, you're not going to have a perfect dissection every single time. Yeah. And part might get removed on one, you might find on another one it's perfect. So it's got to kind of, if you're dissecting 5 to 8 of these, you might find a couple perfect ones in a spot. Because right now we're looking for the labial polyps?
Labial polyps, yeah. And so here are the gills again on this one, and here's the mantle that I've folded back. And part of the mantle, an extension of the mantle near the mouth, are what are called labial palps. And there's 2 of them on each side, 2 of these little flaps. And then as the food is pushed forward along the gills, when it gets toward the mouth, it's sorted and separated by these labial palps. So the mouth of the clam, let me move a little bit more of that mantle tissue. The mouth of that clam is right down here underneath there where the food goes down in. So we have, again, mantle tissue pretty much surrounding the body, the gills, the labial palps, all those can be seen fairly easily when we open up the...
All part of that digestion as far as...
Yeah, or function, the gills, of course, function gas exchange, but also in food capture.
Then a separate mouth from an anal area as far as the complete...
They're both difficult to see in the clam. The mouth is an opening at this part, and then the anus would be here near the siphons where the water comes in and out, flushing waste out of the body.
Is there a way to see those siphons?
Well, a little bit better probably on this one, although they don't show up much like you'd think. They're just kind of indentations in in the mantle itself, into the shell. They might show up better on that one. Well, they'd be down at this end usually. Yeah, I don't know, not too well. But the things are.
Okay.
Is this the one we started on? Yeah.
Yep.
Yeah. Okay. Let's
Look at
look. Yeah, a couple other things are now. So usually, if you're going ahead and dissecting this, you want to look for some more internal structures. We would go ahead and remove the gills. You can either cut those or tear them out. I'll go ahead and use scissors.
I'm gonna hold that for you.
Yeah, I got it right there, I think. Otherwise, I won't be able to
Okay.
cut it. And there we go. Take those structures away. And now we've got situation, okay, if the gills and all it's removed, here's the foot again. And then this area right here is called the visceral mass. And that has some of the internal organs inside of that. And so the next thing you want to do is cut into that visceral mass. And this is a little tricky. I usually use the scalpel for this. You want to cut down in, you want to cut through the visceral mass kind of in a crosswise motion to kind of open it up. See if I can, I'm going to do this without killing myself. So if you cut this.
This is kind of a tough cut too, as far as
Yeah,
the students is.
yeah, you want to be careful here.
cutting
Again,
towards
things are,
yourself.
yeah, things are moving too inside of here. And as you cut that flap away, first of all, you can see, and this is one of the dangers of dissection too we were talking about. If you look at this, it doesn't look really anything like they do in diagrams. It's much mussier than that. And really, when you're looking internally, you'll see a separation of two areas. First of all, probably the easiest one is this green material. This is digestive gland, and this is right up near the mouth. And so this digestive gland producing enzymes and things to help with digestion. This yellowish or more whitish material out here is gonad, which is reproductive tissue, produces gametes. What you can't tell in clams at this stage, you can't tell whether it's male or female tissue. So we give it that very generic name, gonad. And also running through there is the intestine. You can see a little bit of the marks here, but we've got one here that we've done previously that shows it a little bit better. You can see these openings here, these tubes. What we've done is you've cut into this, you'll cut through those tubes. And so the intestine is a tube that's swirling around, winding around inside this visceral mass before it exits the body. And it's surrounded then mostly by gonad tissue. Here again is the digestive gland up here, the green tissue, the yellowish whitish tissue, the gonad, and then the intestine running through the visceral mass.
So that digestive gland would actually secrete into that intestine area?
Yeah, into the intestine area to promote that digestion.
So we looked at basically reproductive a little bit,
Yeah.
digestion, some move. How about like a circulatory system?
Yeah, and mollusks have an open circulatory system, which means the blood is not totally contained within the vessels. It flows throughout the body, but there is a large heart structure. And as you're looking here along the top, you can see this tissue. There's the heart is up in that section. I think we'll open it up with the scissors here.
So up on top, towards
Yes,
that dorsal.
it's on the dorsal surface,
With a hinge.
top of the shell. Yeah, near the hinge. And there it is.
Hold it for you here.
Yeah, it opened that up. And so this is actually the coelom, the body cavity. It's kind of reduced in these animals. And here you can see this tube running through. Actually, the intestine runs through here too, surprisingly. But outside of here, this is the heart. You can see these kind of open, it has these openings. And so that's part of that open system, the blood flowing in, flowing out. But the muscular contractions of that heart then circulating the body fluid around, distributing oxygen and food throughout the body.
You're saying open system, so ours is a closed system.
Right.
Now, how would you describe that?
Yeah, the open system is more like a hot tub or a jacuzzi. The fluid's out there flowing around. The pump picks it up every once in a while, keeps it circulating, but it's not contained within the vessels under a lot of high pressure or, and fast circulation time. So it's not the greatest system in the world, but it's very inexpensive to keep going, and it works reasonably well for mollusks.
Then like ours would be similar to like a closed system, like going to the basement and seeing all the pipes.
Yeah.
Turn the water faucet
turn
on,
on,
high
it's there,
pressure.
High pressure, going to move it.
Absolutely.
Right through there. So there aren't too many more things to look at. There are some kidneys for excretion. They're really hard to see. They're kind of up in this area.
How about any kind of a central brain type?
No, you can see virtually, no head really. There's a few nerve endings and different things like this, but not very sophisticated. These animals live very simple lives. They're burrowers, filter feeders, and so they don't have a very sophisticated nervous system, although other mollusks like octopus and squid, which have developed a much different active, being an active predatory lifestyle, have a much better developed sense organs and brains. So certainly, mollusks have a real diversity in body plan and form, and clams sort of show one part of that.
One question I always had, because it looks very similar to the foot, would be like a find a slug in your garden. Is there any relationship at all there?
And the slugs and snails are relatives. They have the foot, and so the foot is, what they propel themselves along the surface with. They are not though. They have a radula, they have a scraping structure for tearing vegetation. They can live on land. Some of them. Some of them have lost their shells like slugs. So they're related, and this body plan again very versatile. The mantle, the foot, the size and shells that they have has created a very different kinds of animals.
You can really see that bivalve now.
Yeah. You can see how it pops together like that, and you can see those strong adductor muscles which hold it closed. So these animals, like I say, they would, normally the shell would be slightly agape, and then if they're under threat, they'll clam down, or so to speak, and really hold on and make it much harder to pry them open. So even, there's, clams, they take a little getting used to. The anatomy is a little weird, but there's, again, showing a relatively sophisticated body plan, long, complete digestive system, an open circulatory system, expansive gills for the respiratory system. So they're pretty well adapted for the kind of lifestyle that they use, which is sedentary filter feeders.
A nice one too, is, and thanks again, Dale, for coming today and showing us this, but nice too because, again, this is the type of animal you might see at the river or creek that kids might come across and be amazed by seeing the shell.
Unfortunately, freshwater clams are pollution. Some other things have led to some decrease in their populations.
Because
but hopefully
filter feeding?
Filter feeding is one of the problems. Loss of habitat, of course, is another. That with more we channelize rivers and do that sort of thing, they like the muddy flats, the sandbars, and things like that. But they hopefully will be able to reverse that trend.
Absolutely. Thank you so much, Dale.
Okay, no problem. It's a lot of fun.